boys and girls, it's me again. Here we are, we're learning about rocks. I wanted to make sure that you'd be ready for your rock test that's coming up next week. So I've prepared a little bit of information for you. First of all, what are rocks? Well, rocks are formed from minerals. And when we say that, we mean that minerals only have one ingredient. Rocks, they might have a bunch of ingredients. Take for instance, when we look at this granite. It's not just one color, it has little specks, and those little specks are all of the other minerals. So rocks are made of minerals, and they come from bigger pieces of rock. So think about mountains or hills. The rocks come from those bigger pieces of rock. They've broken down into smaller ones. Rocks are made of minerals, and they come from larger rocks. Good. Now we know that there's three types of rocks: metamorphic, igneous, and sedimentary. When we take the first letters for that, it spells M-I-S. Miss, because I don't want you to miss this. Metamorphic, igneous, and sedimentary. Those are our three kinds of rocks. Just like we have different kinds of dogs, and they're still dogs, we have different kind of rocks, but they're still rocks. Metamorphic, igneous, and sedimentary. I don't want you to miss this. Good. Okay, so let's talk about metamorphic for a minute. Metamorphic means to change. When we learned about the butterflies in science earlier this year, we knew that they went through metamorphosis, which means change. These rocks also change. Let's take a look at the two examples that I have. This is shale right here. When we look at shale, it kind of leaves a clay kind of feeling on your fingers. Yuck. So we have this shale. Shale is a sedimentary rock. That means that the particles settled and made the shale. Well, over many years, hundreds of thousands of years, the shale is compressed under pressure and heat, and it turns, or it goes under metamorphosis, into slate. Slate makes a little bit louder noise, and it doesn't leave the clay on our fingers. This is a metamorphic rock. Shale is a sedimentary rock. This turned into this. Okay? They look the same, but there are some differences for sure. The next one is one of our favorites because it's igneous. Igneous rock, as you know, has its own rock song. Now this is a time when you should turn off the tape, go get a hairbrush, go get a wooden spoon, and you can sing with me. Ready? Here we go. Let's sing it loud. This rock is on fire. This rock was on fire. This rock was on fire. I hope you were singing. Pumice and obsidian, both igneous rocks. They were on fire. We love igneous rocks. Next one, sedimentary. Sedimentary, that's my dog. Sedimentary means to settle. Okay, he is a bad dog. Where were we? He lost my train of thought. We were talking about sedimentary rocks. Sedimentary means to settle. Okay, when we say that, it means that all of the sediments, the sand, the calcium, the seashells, whatever it might be, all settled and crunched together to make the rock. So let's take a look at this. Sandstone, we know it's made of sand. Limestone, it's often got bits of seashells in it. We can see that there's little patterns where the seashell might be in it. These are sedimentary rocks. The things that made them settled to help them form into rocks. Okay, when we talk about rocks, there's 4 different traits that we could have. We could talk about the color, we could talk about the mass, the texture, and the scratch. So when we talk about the color, well, we can look at this and go, well, it's red. When we talk about the texture, we could say it's bumpy, gritty, sandy. That's the texture. When we talk about the mass, of course we have to get out our balance and weigh it. I'll do that in a minute. But when we talk about the scratch, that's if it makes a mark on our little tile. And we know that that has a test that goes along with it. So let's take a look at our mass. With our mass, we want to take a pan balance. We make sure that it's nice and even. I'm going to hold it up so that you can see it. Then what we do is we put in our rock on one side. The rock just goes on this side, nothing else. Once we've done that, then we add our weights on the other. 10. Not quite. 20. Oh my goodness gracious. That was too much. So we have to take out one of these. We take this out and we know that we have 10 in there still. So now I need to just add a few. 11. Not quite. 12. Oh, almost. I missed. Ready? 13. So close. So boys and girls, if we try one more, we see if it's too much. 14. This looks like it's about 14 grams. So we write 14G. 14 grams. It means they're balanced. The important thing when we do that is we put the rocks on one side and we put the grams on the other. We don't ever mix them up. I know it's fun. I know we want to put 100 rocks in there, but we do one at a time and we see what it balances out, what makes it equal. Okay, that's important. All right, so we've talked about color, we've talked about the texture, how it feels, we've talked about weighing it and the mass, but we also talked about the hardness of it. And if you remember, we had a little saying that helped us remember. So hang on just a second. I'm gonna get my... Okay, boys and girls, let's talk a little bit about Mohs hardness scale. Friedrich Mohs was a German scientist, and he thought that it was very important for people to tell which kind of a rock it was or which kind of a mineral it was based on how hard or soft it was. We know that because he said that certain rocks and minerals will scratch other rocks or will leave a mark. So if we take this rock and our little tile and we scratch it and it leaves a mark, that helps scientists determine how hard or how soft the rock is. If a rock is a 10, it can scratch everything underneath it. If the rock is a 1, it doesn't get to scratch anything. If the rock is a 5, it can scratch everything underneath it, but everything above it can scratch the 5. Okay? That makes sense. Let's take a look. Mohs scale. It says, how hard is a rock or a mineral? A diamond is a 10, that's the hardest. Talc is a 1, that's the softest. And as you all know, I like to make things a little bit fun so that we can remember this guy. So I'm gonna put together a little play for you. Are you ready? Here we go.
Hey, yo, my name is Mohs. People call me Mo. Hey, yo, how you doing? Cause I like to talk about rocks, don't you know? And I got a girlfriend. Her name is Flo.
Mo, I want a diamond. Diamonds are a girl's best friend.
Well, yo, Flo. I'm not really sure what we're talking about here. I mean, I don't know what the big deal is. Why can't I just buy you some talc?
Talc? Oh, I don't want talc. Talc is chalk. I don't want chalk. You think I want to rock around with chalk on my finger? No.
Well, I don't really see what the big deal is, Flo. I mean, I think it's kind of brilliant. You could walk around with talc on your finger and you'd have chalk everywhere you wanted to go. You could write on stuff. I think it makes sense. It's a good idea, don't you think, Flo?
No, absolutely not. I want a diamond. Diamonds are a girl's best friend. Look it, a diamond is a 10, Mo. Talc. Ew. Talc is a 1, Mo. I want you to think about that.
Well, I guess when you put it that way, only the best for my Flo, so I guess a diamond it is. Right? Right.
Okay, boys and girls, so we remember Flo and Mo. They help us to remember that diamonds are a 10 and talc is a 1. When we go on to the layers of the earth, we're going to talk a little bit about that right now. We have 4 layers of our earth we like to remember. If I have an earth and it looks like this and we open it up, here, I'll close it for a second. Here's our earth. And if we open it up and we look on the inside, we can see that we've got 4 layers. Okay, if we think of the crust, we all know what we have on pizza, right? We all think of the crust as the outside. Well, that's where we live. That's the part that we know about. A mantle, like a mantle on your fireplace, wraps around something. Mantle starts with M, middle starts with M. Mantle is in the middle. Then if we look at the core, we've got the outer core first and the inner core second. If we think of core, it means center. So here I am saying the inner center. The crust is on the outside. A mantle starts with M, and it is a mantle of a fireplace, wraps around. The mantle in our earth wraps around the middle. Here, just like we have an apple core here, we have the inner core and we have the outer core. The inner core is all the way deep down inside. Okay? Those are some ways that we can help remember our 4 layers of the earth. Crust, mantle, outer core, inner core. Yay, good, we're almost done. Woohoo! So let's take a look at our next one, volcanoes. We talked a little bit about volcanoes, not a whole lot. You should know that there's 3 different kinds. There's a shield volcano, a composite volcano, and a cinder cone volcano. When we look up close at them, you can see that the shield volcano is like Captain America's shield turned upside down. Here is a cinder cone volcano, and it's kind of between the shield and the composite. The composite volcano is like a mountain. And for me, that's the one that I think of when I think of volcanoes. Okay, so we've got shield, cinder cone, composite. It has to do with their shape, and it has to do how fast or quickly the lava flows, cools, and hardens. Okay, that is what determines the shape. So for our next thing I'm going to show you, I'm going to get out our graham crackers again because we had so much fun doing that. So hang on a minute, I got to get the graham crackers. I'll be right back. Hi boys and girls, I'm back with our graham cracker and frosting demonstration. We did this in class. I hope you remember just the experiment part and not how yummy it was. So if we take a look at this, we've got our plates. We know that all of our continents and our oceans sit on plates on top of the world, and they're always kind of moving. Well, the graham crackers are the plates and the frosting is the magma. So if we take a look at what happens if I push down and out, right here we can see that a ridge formed, okay? That ridge would be like an underwater ridge that we would find, a mid-ocean ridge. We technically call it a divergent boundary. You just need to know that crazy things happen along our plates when they rub together or when they move apart. Here you can see it made a ridge. So that would be a mid-ocean ridge called a divergent boundary. Hang on, here comes our next one. So boys and girls, when we look at this next one, we can see that the 2 plates are together, but this time instead of moving them apart, watch what's gonna happen. I'm gonna move them so that they go across from each other. When this happens, pieces of my graham cracker break. This would be like what we see with an earthquake, okay? They're moving together, it's breaking, it's crumbling. That would be if we saw an earthquake. Hey, frosting, right? Yum. Our last one is a little bit different. Our last one, we take our graham crackers and our frosting again. But this time what's going to happen is I'm going to take this and I'm going to dip it a little bit in water, and I'm going to take this and I'm going to dip it a little bit in water. Then when I push the 2 together, it buckles. And I'm going to show you sideways so that you can see. See how it buckled and it pushed up? When it pushes up, that's how we get our hills and our mountains. That's what happens when the 2 plates push together, and that's called a convergent boundary. Okay? We just have to know that there's a lot of crazy things that happens along plate lines. We might have earthquakes, we might have volcanoes, we might have mountains or hills that are forming. We just have to know that a lot of different things happens, and that's why we did the graham cracker experiment. Okay? So we've gone over those. I think we're coming to the end of this. Let me double check. I've talked about a lot of different things. I hope that you understand this and that it makes sense. If you have any questions, please make sure that you come see me in class. Have a great night, and I will talk to you later. Bye.